Okay, so what we're going to, I know today is going to be a long day, so what we're going to do is that we'll cover two topics. And what I'm going to do is I'm going to have theory, practice, okay? So the practice will wake you up, kind of like wake you up. Okay, so the quicker you finish the practical part, the quicker we finish for the day. How's that? Okay. A quick recap. What have we learned so far? Huh? So that was just before. And before that? Huh? Come again? Where's the money? That's observation. Before that? No. Ideate is after that. Okay. The four steps again. Understand, observe, ideate, prototype. So we talk about understand. That's where the Ishikawa diagram comes in. We talk about observe. Where's the money? We talk about ideate, brainstorming, right? Next, we're going to talk about prototype. Okay? Is the slide clear for you guys? Okay. So when it comes to prototype, wait for them to sit down. So when it comes to prototype, let me put the steps of prototype into perspective. We start off with understand, observe, ideate, prototype, right? Okay? That's the last step of your design thinking process. So at that point in time, by the time just before prototype, you would have got some kind of an idea that you developed through a brainstorming session. Agree? So let me introduce you to prototype as follows. Take a look at this picture. Is this too bright for you guys? Let me try and turn it down. Whoops. You prefer that? The camera won't like that. I do not know how to switch it off. Just this portion, I mean. So bear with me. Take a look at this image. Take a look at this image. Anything peculiar about this image? Huh? No door. No door where? So you notice that there's a window, there's a staircase, then there's no door here, right? You notice that? There's no door over here. Make sense? This is a real building. This is a building, not Photoshop. This is a military building somewhere in China. Why? The question for you guys is that what do you think went wrong over here? Huh? One at a time. What do you think went wrong over here? What do you think resulted in a building like that? What? Drunk. Most likely someone designed it, and then after that they say, hey, I want to change. They design a building. Chances is that they either have a door there or something like this, and then subsequently they say, no, I don't want a door there. Okay? Now, when we design product, chances is that we design something that we thought, okay, this would be great. But the moment it goes out there, then you realize something is wrong. You need to change the design. Make sense? In Malaysia, for instance, you see a lot of small little shopping area. Traffic goes two ways, then after a while becomes one way. Something changed, right? Why is there a need to change? The need to change because the design wasn't good enough. Make sense? Okay. So the idea of a prototype in design thinking is to avoid this kind of change, to avoid having to make changes after you freeze your design. Okay. So when I say prototype in design thinking, I do not mean this. This is the YF-22 Raptor prototype, the first functional flying model of the F-22. Okay? When I say prototype, I do not mean this. I mean this. This picture I stole from my friend. It's from a science museum, taken from a science museum in Ireland. This is a model of the Concorde before they finalized the design of the Concorde. So when I say prototype, you notice that they are trying different shape of the Concorde, right? Chances is that they are using this paper model to put it inside a wind tunnel to study the characteristics of the shape. And from the shape, they decide, okay, which one of these would be a good model for the Concorde. The one at the bottom is almost looking like the Concorde that we know, right? Those at the top are not quite like the Concorde that we know. Make sense? So when I say prototype, what I mean is more like in engineering terms, proof of concept. You got a concept, you are trying to prove that concept. You are doing something just to prove that concept. Are we okay? So the purpose of prototype is as follows. It helps you have a concept. It helps you evaluate the concept. It allows the designer to get a feel of how the concept fit inside the overall design. Okay? It provides you an avenue to make whatever mistakes that you want and correct it along the way. Are we okay? Let's say I'm designing something. Okay, I'm designing something. It's still in my head. That idea is still in my head. For me to change the design, it's just changing it in my head. How much does it cost me? Virtually nothing, right? So let's say once I have it in my head, I say I quite liked it. I scribble it onto a piece of paper. Okay. Then I say not quite right. I use an eraser, scrub it off, and redraw that line. How much would it cost me? A couple of seconds, a couple of minutes, redrawing some bits of pencil, lead, and things like that. Now, if I say design is good, I sign off, someone built the first prototype. Okay? The first item comes in. The first functional working prototype comes back. I test it. I don't like it. I change it. How much would it cost me now? The cost, I have to change the prototype. I have to go and change the design on a piece of paper, go all the way through until, you understand? So all the component that I buy to build this prototype could be wasted. I change it, right? Or I throw it away. I say, I don't want this anymore. And I may not be able to reuse it. I throw it away. Can you dim the front? So someone is here to help us. Can you dim the front light? Thank you. So the moment you build a first functional working prototype and you want to correct an error, the cost incurred in building a prototype that is not quite what you want is a cost involved. Compare that to me rubbing off a line on the paper, compare it to that of me just changing my mind. Okay? Now, assuming that the prototype is all done and you're happy with it, okay? You say, let's build 1,000 pieces for some kind of a pilot or trial. That 1,000 pieces, or say, let's not say 1,000 pieces, let's just say 100 pieces. You take that 100 pieces, give it to the employees or your friends and try. Okay? You have built, say, 100 pieces. After that 100 pieces of trial, comes back and say, something isn't quite right. Maybe let's say it's a mobile phone and the touch portion is not sensitive enough, or the touch is too sensitive, or a certain switch doesn't work, or it bends, or it breaks, or things like that, right? You're going to change it. So the money incurred in producing that 100 pieces, down the toilet. Correct or not? Versus me, earlier on, I just changed it in my head, or I just changed it on the piece of paper, or I changed on the first prototype. Now, that 100 pieces, I have to change, right? Now, imagine, after that 100 pieces, whatever changes that you have made, you say, okay, that's fine. You're going to now build a small pilot run, a few thousand pieces. At that point in time, most likely, with a few thousand pieces, you would have incurred price for a mold. A small plastic mold would have cost you like 30,000 ringgit. Maybe with a drop in ringgit right now, maybe a lot more. Okay? Now, what is going to happen? I've got to learn that. What is going to happen is that the earlier you correct your mistake, the cheaper it is. Okay? So the technique with prototype is that you want to discover your error as quickly as possible so that you do not repeat them later down the road, because it's going to be costly. Are we okay? So the principle behind, like how I have just described it, is that your concept is tried as early as possible. So the strength and weakness of your concept is tested as early as possible. Okay. Now the other way of describing the philosophy is described by, you know the video I show you guys? Peter Skillman says this. He said, enlightened trial and error succeed over the planning of a lone genius. What this means is that if I take a bunch of average guys versus one genius sitting in his room, and the bunch of average guys going through this trial and error, right? But it's not just dumb trial and error, it is an enlightened trial and error, which means you make an error, you learn from it, you correct it. You make some more errors, you correct it, you keep correcting that, right? The average team can outperform a lone genius sitting in his room. Okay, so I'm going to share with you a few techniques. Then after that, you guys is going to do an exercise, maybe 2, before we move to the next topic. What I want to show you is a technique called mock-up paper prototype. If I have we'll see. If we talk about tabletop simulation, we'll talk about body storming. Body storming sounds like a dance, but it's not much of a dance. So let me talk about mock-up. This is a project that I did when I was in Intel many years ago. So let me tell you a story behind it. You know, Telekom Malaysia, that building in Telekom Malaysia in Bangsa, people could just go in, I was told. You could just go in and out of the offices, and a lot of people just walk into the offices, take their laptop, and just walked off. Okay? So then Telecom then approached a friend of mine. He says, can you do something about it? So the way people do it is that they open up your laptop, find a cavity somewhere, insert an electronics with a battery inside. That electronics constantly sends signal. So as you leave a certain area, if they detect the presence of that electronics, they say, something is leaving. Okay? Now the moment you open up the laptop, you put something inside, the manufacturer is going to say, warranty void, nothing to do with me anymore. Okay? So then what people do is that they put that electronics inside something that looks like a USB thumb drive, right? So they shove it into they just insert it into the thumb drive. Or they insert it into a serial port or something like that. They locked it into the serial port. Make sense? And then, so you got a piece of electronics stuck onto your laptop. Now what happened is that this thing sticking out, every now and then someone pressed on it, it damaged the board, even worse. So then this friend of mine came to me and said, hey, is there a way to come up with a solution? So at the end of that, we designed something like this. But let me show you the process as to how we get there. We start off with a piece of plasticine. That was many years ago, and that's my son plasticine. He's a little boy then. So you see that piece of plasticine at the top, that's the size of the electronics. That piece? That's the size of the electronics. So what I wanted to do was, you know, all laptop has got this little slot where you could attach a Kensington lock to it. I wanted to attach this onto the Kensington slot. I don't want it to go into an electronic port. I want it to go to a mechanical port. And then the moment you use up that lock slot, you cannot lock it, you cannot tie it to anything anyway. So what I did was I said a lock that goes there and another slot for you to daisy chain. So this lock onto a laptop, then the chain lock onto this item. Okay? So what we did was that we took a lot of laptops from the office and we said, okay, the design is going to look something like this. So what would happen if this was to be the design with this laptop? We look at it and say, there's no issue whatsoever. We look at another one, no issue whatsoever. Look at yet another one, very similar, no issue. Then we found a laptop where the slot is behind the display. Then we realized that if we have this, it's not going to work. If we have this, what is going to happen is that you cannot open your screen as wide as you would like it to be. Okay? So we thought, okay, if that's the case, this piece of electronics has to lie flat. It cannot stick out anymore, it's to lie flat. So we did that. Then we got the industrial designer to come and redesign and say, hey, it's got to lie flat, and we have some discussion. They gave us some idea, and when they came back with the drawings, we cut styrofoam based on the drawing they gave us. Okay? And again, we repeat the same thing. We take it and say, what if it is this laptop? Can I still put a thumb drive next to it? Understand? So I'm using styrofoam, I'm using paper, I'm using whatever I can to test the product as though it is in the final stage already. Okay. Now, when we do all those things, the other thing that we are constantly making sure is that it has to look good. I don't want to be an engineer where it's a square little thing. I want it to look good. So amongst the design that all works, we pick one that looks nice. So, So we came up with a design that looks like that. Okay. Now, when we released this, a company in Sweden says, can you quote us? I've forgotten the number, 17,000 pieces or 70,000 pieces. This is not Intel business, so we don't do it. We gave it to someone else to do, but we gave the idea to someone else. Okay, you can't see it here. There's a little slot that this is attached to the slot, and you can attach your cable to that. Okay, you understand the concept? The whole concept is before you finalize the design, you want to test it as though it is in the final stage already. So from plasticine to styrofoam to whatever form that you want. Okay. The next one of next kind of mock-up is this. This guy, what he wanted to do is that he wants to design a flip phone, right? And he's trying to figure out the dimension. Is it too long? Is it too short? What about the angle? So he could just test it like that before he does anything. Are we okay? Clear? Okay, next one. Stop me and ask question if you are not clear, okay? Paper prototype. Paper prototype is especially useful if you're writing software and there is a graphical user interface. Okay, I'm going to show you a video. The audio is not important. What these people are trying to do is that I think this video is something like 10 years old. They're trying to paper prototype a web-based email. Oh, I'm sorry. The other side? Okay. Okay, it looks like playing, right? Now, many years ago, one of a team from your senior, they actually wanted to write the software, and they asked me to be the guinea pig. So I sat down there. After pressing a few buttons, I stopped. They asked me, what's wrong? I said, I want to go back, but there's no button to go back. Okay. Now, what you see is that they have corrected it so many times that there is no more mistakes, right? They have perfected it. They know all those features required. the other thing that's good in this sense is that even before they have written a single line of code, they already know what they need to do, number one. Number two, once you know that, when you ask someone to write a code, you know exactly how it's going to perform, and you know that there will be no more mistake. There's going to be very little change, if any. Make sense? So when you do something like that, what do you think is the most important thing? What do you think is important when it comes to testing it like that? Scenario. For instance, if the guy say, do a scenario of you sending something. Okay, that's one scenario. Do a scenario of you sending someone something with an attachment. Do a scenario where you're replying someone. You understand? The different scenario. If you test it with multiple scenario, then the coverage is good. If the coverage is not good, then what is going to happen is that you're going to miss some cases. You didn't test it. When you don't test it, there's a chance of an error being inside. Are we okay? Oops. It's so tall, I can't. Okay, I want to show you this other video. This company is called Tektronix. Tektronix makes this electrical equipment that measures a signal. Okay, so what they are doing is that they've got a new design. Currently, they only have the design, the facade of the design, on a piece of paper. So they're giving someone an instruction to do something, right? And then you see the reaction of the other person.
Remember, your task is that you want the trigger level to be exactly 435 millivolts. I'd like to walk you through one thing again. What you had done before was press level.
Right.
And the message came up and it said keypad enabled for trigger level entry.
Oh, I see what you're saying. Yeah.
Okay.
There's a pause.
What are you looking for now?
For a keypad.
Okay.
There's a pause. He's asked, what are you looking for? He said, looking for a
Display
keypad.
message reads as follows. Keypad enabled for trigger level entry. Okay. Now you want to set the level to 435 millivolts.
Okay, and which keypad are they referring to?
He's asking
And
for
this
which
message
keypad.
appears on this part of the display, and it says keypad enabled for trigger level entry.
Ah,
So set the trigger level to 435 millivolts.
I would press 4, 3, 5, shift M, small m, for milli, and since it's, let's see, have we told it? Yeah, you'd said we'd already pressed level, so it would know then we're dealing with millivolts, not milliseconds or whatever, and then I would press enter.
The waveform that you're seeing, which is about a full period, okay? The whole waveform is now intensified.
Okay.
Okay. So the next thing that you'd want to do
Is there should be something to allow me to do one of two things. I would expect I could move the horizontal, the seconds per divs knob here, and have that intensified portion get smaller.
Okay, you notice that for this design, the first one, he paused, and then the guy giving the instruction say, what you're looking for, he say, which keypad? And the second time, the same design was put to another user. He asked, which keypad? The third one was of a different design. The fourth one, again, he says, there must be a way for him to do something. The design is the same. Everything on the button on the first and second design are the same. So for this design, they do not know which keypad to use. But on the third attempt, second design, the guy just said, he'll do automatically. It's very intuitive, right? So by just using this paper prototype, you could actually figure out what is wrong. Now, this paper prototype is more than just paper prototype. Asking someone to try something out as though the product is there is called body storming. Body storming is like role playing, right? So you imagine that the product is there and you are role playing as though you're using the product. Are we okay? I'll show you another video that talks about role playing. I'm going to skip this. Okay, maybe not. Okay, let's try this. You know, long time ago when people have got warfare, on their bench they have got like the army is coming through this way, my army is going through this way. So they're doing a simulation of what is going to happen on a tabletop, right? So sometimes in a lot of cases when you design something, you could actually do a tabletop simulation or a mental simulation. Let me give you an example. Let's just say you work in a factory. So the factory has got the block on the green and gray block on your right is an office. That funny ice cream box at the top is, let's just say that that's a factory. You've got a main entrance on the bottom. So if this company says, you know, all of us are issued with some kind of ID card, right? So if the company say, you have to come in to the premise with your ID card. Okay? Sounds good, right? We all have one. And then you drive through, just scan your card, you go in. On your way out, scan your card, you go out. Okay? Do you see any issue with this design? No issue, right? Come in, scan your card, boom, gate open up, go park, do whatever you need to do. Goes out, scan your card, boom, gate open up, you leave. Correct or not? So like I said earlier, I said it's a scenario. So if the scenario of you driving to work, you go through, you take your badge out, you scan, boom, gate open up, you go in. On your way home, you drive to the gate, scan your card, boom, gate opens up, you go out. No issue, right? Let's take a scenario of, let's just say your spouse drives you to work. Your spouse drives you to work. So then you go there, your spouse is driving, drop you off, and then your spouse goes to, it could be your spouse, it could be your siblings, go to his or her other workplace, right? So as you enter, your spouse or your siblings grab hold of your ID card, scan it, opens up, you go in. You drop, your spouse or your siblings drop you off, and then you go back, you go to work. Your siblings or your spouse comes to the gate, looking, cannot go out. Agree? Now the moment you identify this, then you start thinking about that. You as a company or a designer of this system is going to think about, should we issue a spouse or a siblings card? Or should we issue a parking card or something like that, right? Make sense? So this kind of simulation, mental simulation or tabletop simulation allows you to identify this kind of errors. Only if you apply the right scenario. If you did not apply the right scenario, you're just going to miss it. Are we okay?